Europe is burning, vast forests have been reduced to ashes. But as I began reading the research, I realized the situation was far more complex than I initially thought.
Europe is on fire, and the internet is split right down the middle. It's all arson. No, it's all climate change. Okay, what if neither one is the whole story? This summer, thermometers in France, Spain, and Greece flew past 40 degrees. Whole forests turned to ash. And when I started digging into the research, I realized this thing is way more complicated than a hashtag war. Scientists actually have a name for this. They call it the perfect storm, not one villain. 3 separate pieces, lining up at exactly the wrong moment. Today, we're placing every single piece. Let's start with piece number 1. The spark. A forest doesn't just decide, today I burn. Something has to set it off. Sometimes it's lightning, sometimes it's power lines, sometimes it's a campfire nobody bothered to put out. And yes, sometimes it's people, careless or not. That's why so many of these fires in Europe are being investigated one by one. Some point to human causes, some point to nature. But did you start all of this? Me? Alone? Never. Because if a spark lands in a green damp forest, it usually dies in a few seconds. Which is exactly why we need piece number 2, the fuel. And there's a third piece too. We haven't touched it yet, but let's crack the fuel problem first. Let's get into this storm. We just said a spark alone isn't enough, but first, let's answer this. Who or what is usually creating that spark? Researchers say the vast majority of wildfires in Europe are linked, directly or indirectly, to human activity. Campfires left burning, cigarette butts, farming practices, power infrastructure, and sometimes, fires set on purpose. Lightning? That's a small slice of the pie, so nature isn't sabotaging us nearly as much as we think. We're the ones creating most of these sparks, most of the time without even realizing it. But here's where it gets interesting. Let's take the exact same spark and put it in 2 different environments. In the name of science, I will try not to burn down the lab. See that? In the damp plant, the spark dies instantly, 0 chance. But in the dry one, there it is. Great. Only my theory caught fire, not the lab. The spark itself never changed. The only thing that changed was what was waiting in front of it. And that tells us something important. The real culprit is rarely the spark. It's what the spark lands on. Piece 1, locked in. But now the real question is, what made Europe's ground this flammable in the first place? Let's move to piece number 2. The fuel. Why have parts of Europe basically turned into a matchbox? Researchers point to 2 separate but connected processes here. The first one is a slow, long-term shift. Over the last 50 years, millions of people left the European countryside for cities. That means traditional land management, grazing animals, clearing brush has slowly been abandoned. And according to the research, that leads to uncontrolled overgrowth. Bushes and small trees pile up year after year and nobody notices. Until it's a massive stockpile of fuel. But what makes 2026 truly different is a second, much newer finding. This year's winter and spring were unusually wet across France and Spain. Some regions saw one of their wettest winters on record. That rain triggered incredibly fast growth in grasses and shrubs. Then, summer hit, and all that fresh greenery dried out fast under extreme heat. An expert from Europe's Weather Forecasting Center says this: wet winter to dry summer, whiplash is one of the most critical factors behind this year's fires. Scientists call it hydroclimatic whiplash. Nature grows a huge stockpile of fuel, then bakes it dry in an oven. Look at this. These are literally the same plant, just a few months apart. It's like nature sabotaged itself. First, it grows everything generously. Then it turns that same generosity into fuel. Feel this. This isn't really a plant anymore. It's basically paper.
You see how easily this crumbles? Now let's try this big dry branch.
Piece 2, locked in. We've got a spark. We've got plenty of dried out fuel. Now let's look at the final piece that turns both into a real catastrophe. Weather. During some major heat waves, a long-lasting high-pressure system builds up. In English, this is often called a heat dome. And that's a real meteorological term, not something the media made up. In the name of science, this time, I'll actually be careful. A tiny spark of light, no matches involved, just compressed air setting it off. Okay. Small honesty break. The atmosphere is not literally a giant fire piston, but the same physics is at work in both. Air heats up when it's compressed. I did that in a few seconds, right here. The atmosphere does it for miles and for days. Air slowly sinks. It compresses. It heats up. It blocks clouds from forming. And then the sun keeps baking the ground, day after day, under a clear sky. And that is not good news. Because when this drags on for days, it dries out that fuel carpet even further. Humidity drops. So, is this actually connected to climate change? Back in 2021, scientists from Stony Brook and Princeton studied a similar heat dome over North America. They calculated that a high-pressure system like that would have been roughly 150 times less likely without human-caused climate change. And this summer, a similar calculation was done for Europe. The World Weather Attribution Network studied the June 2026 European heat wave. Their rapid analysis estimated that today's temperatures are roughly 200 times more likely than they would have been 20 years ago. They even said heat like this would have been nearly impossible under the climate conditions of 50 years ago. Here's the thing, climate change doesn't replace any of these three pieces. It's not the spark, it's not the tree, but it makes this piece far more dangerous. Wait a second, is the fire making its own weather now? A wildfire in France's Gironde region produced the country's first ever recorded pyrocumulonimbus, a fire cloud. This massive electrically charged smoke cloud generated its own lightning and violent winds, which then sparked new fires. Experts call this a genuine turning point. This phenomenon used to be something you'd only see in the most extreme fires in North America or Australia. On their own, none of these three pieces looked powerful enough to change the world. But together, this is exactly what scientists call the perfect storm. People were looking for one single villain, but the disaster only happens when all three collide at once. A spark, usually human, sometimes natural, dried out fuel. Years of abandoned land, plus this year's strange wet winter, dry summer surprise. And the weather that turns it savage. Heat waves, drought, wind, even storms the fire creates for itself. Here's the good news. Once we understand these three pieces separately, we can actually do something about each one. Better monitoring and awareness to prevent the spark. Land management and rewilding grazing programs to reduce the fuel. Satellite-based early warning systems to see the weather coming. Up until now, we've only talked about people, houses, and holiday resorts. But when these three parts come together, we're not the only ones paying the price. A fire can spread in seconds. But a squirrel, a hedgehog, a turtle can't escape at the same speed. In the areas hit by the fires in France this summer, experts say that in some areas, almost no living thing survived. The power of the fire was so great that for many species that didn't have time to escape, there was no escape. And even after the flames are extinguished, the story doesn't end. For birds that feed on insects, that forest becomes uninhabitable for a long time because the food itself is gone. Because the real population we've forgotten lives right under our feet. The insects in the soil, the pollinators, the decomposers. After a severe forest fire, it can take almost a decade for this community to return to its former diversity, according to some studies. Even for those who escape, the danger doesn't end. With the first rain, the ashes mix with rivers and lakes, and this affects not just the creatures living in the forest, but also those living in the water. So what we call perfect storm isn't just our story. When the spark, fuel, and weather conditions come together, an entire world that has lived on these lands for generations is simultaneously at risk. The good news is that the solutions we just discussed, land management, regrazing, early warning systems, protect this unseen crowd as well. Thinking about them means thinking about all of us,